Good morning, everybody. So,
Good morning.
Good morning,
can you
Chief.
hear me clear and louder?
Good morning, Chief. Yes.
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 Yeah. Can you hear me clear?
Yes, Chief.
Yes, Chief, clear.
Yes, Chief. We can hear you.
So, okay. So, last class we stopped here. We have this is the camshaft chapter of engineering knowledge motor. So, we have seen there is a backlash is provided.
Yeah, Chief. It's clear.
Yeah.
It's
Tell me.
clear.
Yeah. Somebody tried to speak something. So, okay, this last class, well, we have stopped here, and we have seen that in the gear drive, we need to give a backlash. That certain clearance we'll have to give, so that when it engage and disengage, there is no interference between the teeth. If we don't give this backlash clearance, then there will be interference, and there will be mechanical damage. So to avoid that, we need to give the backlash. But this backlash has to be as minimum as possible. So because if we have the backlash, this backlash when we are for the reversible engine, when we are running operating in opposite direction, that is the astern direction, then what will happen because of this backlash, will be having a timing. There will be, it will affect the timing of the uh, engine, that is the fuel timing as well as the that exhaust valve timing. So that's why we keep it as minimum as possible. And it is because astern operation is much less compared to the head operation, it is acceptable. It affecting only during the astern operation. If it is a unidirectional engine, four-stroke engine, or the medium or high-speed engine, there is no problem. It is running at in same direction, but still the backlash has to be minimum. We keep the minimum backlash, but it will not affect the timing. Now we have seen that feeler gauge we use to check the backlash, as well as dial gauge, as well as lead wear. It means we have a gear. So we have the gear teeth which will mesh together with the another gear teeth from here, and it will mesh together here. But there will be another gear teeth this side which will have clearance, and this is the backlash clearance we are talking about. So this clearance, we can turn this driving gear, and a driven gear will rotate in opposite direction. It will make contact here, and we can put a filler gauge in this clearance, and we can measure it. That is the filler gauge by. Dial gauge, we have seen that the next teeth for the driven gear will be here somewhere. So there will be a space through which we can put the dial gauge, and it will be on the fixed base, that is magnetic base. So once it has in contact, we stop the turning gear, and then we rotate in opposite direction, the turning gear in reverse direction. But once this clearance, this is moving in this direction now, this should just make contact. This should not move in opposite direction. If it moving in opposite direction, we'll get a wrong reading, because we want this clearance to be measured only. So this can be only done, the skill comes with the experience, and initially it will be like more trial and error method. It is a trial and error method, and you'll have to measure many number of time initially. Then you will acquire that skill. You can get that skill, but still it will be more than one time you'll have to do, so that once it moves you stop. Then you know how much is the reading. It will be less than that, so you again do the same procedure. Once it's coming, you monitor this reading, so you know it is less than that, you cannot reach, you stopped it before that. And then you can check if it is in contact, or again you move slightly, so you will come to a right correct reading. But this is a difficult task if you do it by this. But another one is the lead wear. Lead wear, what do you do? When you are turning this, it means in this direction we are turning, we'll be putting the lead wear. So what we do, we put the lead wear here, and this diameter should be more than the clearance. So what will happen when we are turning this, it will make contact here, and this lead wear will get squeezed between this, it will get compressed, and then it will give a uh, after compression. Once we remove this, it means once it is moving this way it will come out, and once it come out, the minimum that thickness we measure, and once we measure that thickness, that will be the our backlash. It means backlash is always opposite side clearance of the contact. This contact you have, and this side is the backlash. That's what we check it, and then we measure it. We keep it as a record, as well as we compare with the. Yeah, that's found. Tell me.
Good morning, sir.
Yeah, good morning.
About the lead wire clearance checking.
Yeah.
I mean, if the one piece is touching the other one in the other side, is that not the maximum gap? I mean, to put the wire and then to squeeze it, we should have to be more clearance, yeah. But if the teeth is touching to one side, the other one is the maximum clearance, I think. So how can we check by the lead wire?
So lead wire, when you put lead wire, okay, this is moving this way, this direction. On this face, let us do this way. So this is the our one teeth. So once this teeth is moving in this direction, okay, it has not engaged. It means this will yeah. So what will happen? This teeth was here, is in this position. So once it is moving inside, we put the lead wire here. Because this side will not make contact. So which side will make contact? This side will make contact with the driven gear. So this is the teeth which will make contact here. So when this is moving, okay, it is entering. Before that only we put this on this surface, we put the lead wire. Once it is entering, this there will be different clearance. It means if you see the clearance at this point there will be one point which will be a minimum clearance. And this side above that point and below that point, there will be higher clearance. We are interested for minimum clearance. So once you put it, this is engaged. This will be in contact. Once this is in contact, what will happen? This teeth will move, because this teeth will move in this direction. And you have already put the lead wire. Once it is coming, pushing this, what will happen? This clearance will keep on reducing. And at one point, it will be minimum clearance, and it will get keep on compressing and that point, but along the length it will not be uniformly compressed. It means it will be, for an example, this is the lead wire we have put, so the compression will be like this. So this is the minimum clearance depth of this lead wire after compression that we are interested about. So that is the our backlash. Because it is a curve, it will not be a same clearance. So this clearance will be a minimum. It will get compressed like this. So when you put it, it was a flat. It was a, this is the surface and we have put a lead wire. But when it is compressing, it will make a shape like this. And this is the minimum clearance. After removing, we do measure where we get the minimum clearance, and that is the backlash we have. Teka, is it clear to you?
Sir, now is
As,
okay because I understand it now. Before the gear is touching, when the gear is outside of the other gear, the driven gear,
yeah,
we put the wire. So now it's clear. Okay, thank
yeah.
you, sir.
So two of you raised hand. Who are these? Okay, Melissa, tell me.
Okay, thank you, Chief.
Yeah,
My question is on the backlash clearance.
yeah.
When we are checking backlash clearance, do we check on one point or just we take few checks? Because if the wear is not uniform, we cannot conclude that the one what we get is a backlash clearance.
Yeah, we check the different point. We have the access. So along the flank, this is the flank. This is our gear teeth. And this is the, for an example, this is the flank. So on this flank, we take more than one reading. We have the access we can take so that we know. Because if it is misaligned, then that happens. It will get worn out not uniformly. Otherwise, it should get worn out uniformly. We have seen previously that if it is misaligned, certain point will be in contact, other point will not be in contact. That shock load will come. So this will get worn out faster than this. So along the flank length, we measure different point. We do measure to ensure that if it is uniformly worn out or not, if there is any misalignment or not. And this we take the more than one reading we do take along the length, this length.
Chief, just my question was not just this one. I mean, we can take around the gear, just the circumference of the gear, few just contact points, or just only one.
So you may, okay, I understood now. Your question is not for one gear, it is how many reading you take. So you
Yes,
take, depending on number of gears, you'll be taking, not all the gears you'll be taking, but you can take sampling. It is called sampling. So you take maybe 10% you take. Understood? But it will not be each gear we don't check. So after we take sampling, we based on the visual inspection, we can see the condition of the gear, and accordingly, it is the professional judgment we can take. So how many gears will be taking? Around 10% for an example, as I told you. So number of gears we know, we take the sample in between 10%, that will be the reading, and we can get an average. And we can even check that are the gear worn out is uniform or there is a difference. It can happen because of the misalignment. One of the reason we have seen there can be the contamination of lube oil, that also can cause misalignment, also will cause uneven wear down. So that you'll have to judge by visual inspection, but it is a sampling. It is not all the gears is not taken, backlash is not checked. But visual
okay,
inspection,
thank
all
you.
the gears teeth has to be checked. Clear, understood, Melissa?
Yes, understand. Thank you.
So now this description, if you see, it is same exactly. It's written. So we running gear, it means the when it is new engine, then you'll have to check that new engine, it is 1-2 hours operation. We stop the engine and we do check when it is delivered from the shipyard. And old engine, it actually, if the gear is running well, 6 to 8 thousand hours, it should last. There should not be any problem. That initially we must check that yes, everything is okay. That's why we need to inspect the gear, and we remove the cover, and then crankshaft, rotate the crankshaft and the turning gear, and we can examine all the teeth visually. And the roller, we inspect the each individual roller has to be turned. Each and individual roller, if freeness of the roller, we do check if it is a roller drive, means the chain drive. And the lube oil pump you must run so that the spray, as we have seen, that if this is the sprocket and this is the roller, so there will be oil flow in upward direction as well as the downward direction, because our engine is a reversible engine. So this roller will carry before it reaches to the sprocket. Before that, the spray has to be given. So oil spray has to be checked because there are nozzles. This nozzle has to be checked, and you must start the pump and check it is nozzle is not clogged, and it will spray onto the roller, and roller will carry that oil, and then you'll be having the elasto hydrodynamic lubrication. Gear and the roller both will have elasto hydrodynamic lubrication, and the spray direction will be in both direction, because sometimes it will rotate in this direction. It means the chain is, or the gear teeth is moving in this direction, and it has to be in opposite direction also, because sometimes it will be in this direction. So that's why there will be spray in this direction also. Suppose it is unidirectional engine, so we don't need here another spray. We can have another spray only here, because it is load is released here. So during the loading, the lubrication has to be there, and it is elasto-hydrodynamic lubrication, which last class I had explained to you, and plus elasto-hydrodynamic is covered in bearing chapter also. So this flow spray has to be checked also by starting the pump, and you must check the flow. And all the screw, there will be screw fastening bolts, clamping of the clipping of the pipes. These all has to be checked, because it can become slacken because of the vibration, and that can damage your gear as well as the chain drive. And every 3 months, once initially we know that everything is okay in normal condition, every 3 months periodically we must check the inspection of the our chain drive and the gear drive. Now, if for an example, gear train, so if it is noisy, because gear will produce more noise because of the rubbing action, but because of the actual movement of the shaft, there will be a rubbing action. So because of that, noise will be more compared to the your roller, means the chain drive. But if noise is excessive, you need to immediately investigate. You cannot run the engine in that condition. Your roller will get damaged. It will even break. So, and immediately it should stop and investigate. And if required, roller has to be replaced. And suppose roller is damaged, you need to make port. Then in that case, you'll have to run the engine at lower load, so that you can make the port and then replace the defective gear wheel. If it is minor damage, we can dress it. But if it is an extent of damage, if high, then you'll have to replace it. There is no other option. So So the lubile system, if like the wear debris means we have the property of the lubile which cleans the surface where it lubricates. So there will be some wear down that should not retain there. It should that should not precipitate and remain there. It should be washed out by the lubile. That's why lubile has got a detergency and dispersancy property that helps us to keep it clean. And gear will, as I told you, 6,000 to 8,000 hours after delivery of the ship, it running okay. It means it is okay. It means there is no problem. Then we can go for the normal maintenance as per the routine. So it may be annual. It depends upon the manufacturers. Annually, we can do after that 6,000 to 8,000 hours. So this backlash, this is the measurement which we have already covered, that filler gauge gap between the teeth flank we measure, opposite side of the contact, and the dial gauge, as I told you, it is the most difficult, but you can acquire that skill with the time, and you can measure it by the dial gauge also. And the lead wear. Lead wear, we must keep the lead wear. It means 1 to 2 mm. We know how much is the clearance. It should be lead wear should be more than that clearance so that it can get compressed. Otherwise, you will not get the rating. So if large compare with the reading, it's provided that how much should be the limit for the clearance in the manufacturer's manual. And then we must check that if the deviation is large, we must check the bearing. It can happen because of the intermediate fill bearing. It has dropped and the clearance has increased. What does it mean? This is the, for an example, so this is one wheel, this is another wheel, and there is the center point, this is center point. It has got, means it is supported by the bearing. Now bearing has, because of the bearing, clearance has increased. So what had happened? It has dropped. So you have the teeth will move downward, and that will cause the higher clearance. It means teeth is not worn out. Because of this, bearing also can happen. We must check that if the bearing clearance is okay or not. If it has dropped, the clearance also will increase. Backlash will be increased. So this is one of the arrangement of the gear where we have the idler, two intermediate. This is the crankshaft and the camshaft. And in this case, this one, if you see, your camshaft is located at higher height. The distance between the center to center distance between the camshaft and the crankshaft is high. So we have actually, in this
Chief,
case,
your voice is broken. We cannot hear you.
is it clear now? Can you hear me? So, is it clear? Can you hear me?
Now we can hear you, Chief, yes. But before we cannot hear anything. Can you back a little bit?
So from this diagram or previous slide? So let us see this. If the deviation is large, that
Previous,
is the
from
clearance.
previous, Chief.
What did you say? Say again. Can you hear me or not? So a large deviation, in that case, what will you do? You must check like if you see this.
Okay, Chief. Okay, go ahead, Chief. Okay. Yes, now we can hear, but your voice was really broken before.
Yeah, that is connectivity, because in between it was got lost to the internet, then it came again. So because of the connectivity, it had happened. So if you see this intermediate wheel, suppose it has dropped because of the bearing, it is supported by the bearing, then the clearance will increase. In this case, this diagram, if you see, uh, so if you see this diagram, the center to center distance is high. Whereas for, we have seen the Sulzar, we have here the camshaft. And our fuel pump is at the lower position. This is the fuel pump platform. In this case, once the center to center distance has increased, this idler diameter and the number of idler is increased, as well as the diameter has to be increased to avoid the increasing of the width. So these are the arrangement, one of the engine arrangement you can have for the slow speed engine. So we have seen the advantage, disadvantage of the center to center distance. If you keep high, that's why BMW uses the chain drive. Chain drive, there is no problem. You can increase the center to center distance so that we have reduced the high pressure pipe length. So this is the 4-stroke engine where we have the gear drive. This is the crankshaft, and this is so again, I'm coming broken. So is it clear now? Tell me. Is it clear?
Chief, we cannot hear you. It's already a long time.
ምንም የሚሰማ ነገር አለ።
የሚሰማ ነገር የለም። Exactly.
So can you hear me now? Because it's internet is coming and going. I don't means that is the connectivity problem. But can you hear me now? Clear? Can you hear me? Hello?
Sir, still your sound is broken.
So can you hear me now? Is it clear?
Yes,
Chief,
Chief.
we can hear you, but can you bring back to 2 slides backward, because we didn't listen anything.
Okay. Are you talking about this?
Yes, Chief,
Yes, sir.
exactly, from here.
Yeah, okay. So the lead wire, we have seen how we take.
Yes, from here, Chief. From here.
What did you say? So the lead wire, we put it where we put, we have checked. Now the lead wire diameter should be more than your clearance diameter because it will get compressed. Otherwise, it will not get compressed. You'll get the wrong reading. And this, if their deviation is high for the gear drive, then what you must check one thing, that is the intermediate fuel bearing. Because if the bearing is clearance is high, what will happen? It will drop the bearing, the wheel will drop and the clearance will be, backlash clearance will increase here. So you must inspect the intermediate wheel bearing. And this one, what I had told that this is the center to center distance between the our camshaft and the crankshaft is high here. If distance is high, number of wheel we'll have to increase, as well as the diameter of the wheel also will be increased. Because in this the Sulzar we have seen we have the crankshaft as lower level, camshaft and the crankshaft distance is less, so that we can have less number of idler as well as the diameter is less. We have advantage and disadvantage. We have already completed that portion. What are the advantage of putting the camshaft is a higher location, and what is the advantage of disadvantage of putting lower location. Now for the four-stroke engine, in four-stroke engine, we have this is the crankshaft, we have a gear, and then there will be an idler. But in this idler, if you see, this is this is idler is like this. So this is in contact with this. And this is in contact with this. So you can have this kind of arrangement, and then this is driving your camshaft. So, and V-type engine exactly identical. If you see this side and this side, both are identical. You can have an arrangement of gear like this. So, this is the number one is the camshaft sprocket. This is 1, 2, 3, 4. That's what it is in the skyware, and intermediate half, and then camshaft sprocket, and then crankshaft sprocket, which is intermediate. One is intermediate, and then the crankshaft at the bottom. Now the roller chain, what we have, the medium speed engine, that is the unidirectional engine. Also we can have this chain drive, and two-stroke engine BMW, we have the chain drive. Now this chain drive, you don't have this backlash, because you don't need backlash, but there is other clearances we need to check. And once backlash, as I told you, has a problem for the reversible engine, where when you reverse it, your timing will slightly change because of the backlash. Whereas for the chain drive, if the tension is correct, then there will not be any problem with that. That backlash is not there in this case. And if it is unidirectional engine, four-stroke engine, there is no problem, because it is controlled by the CPP, control the pitch of the propeller. So in Aston movement is compared to the admission movement is less, so there is it is acceptable that. And two-stroke engine gear drive we are using for Sulzar and Mitsubishi. They do use the gear drive, whereas the BMW, they are the main three major engine maker in the world. So BMW use the gear drive. The BMW we use the chain drive, and the Sulzar and Mitsubishi we use the gear drive. So the axial movement of the crankshaft, we have seen the crankshaft has got the axial vibration, so there will be a movement. So there will be a sliding motion between the gear flank. It means because of this, this is the gear flank, it means there will be a sliding motion between the, because crankshaft is axially is vibrating, there will be a sliding movement on the gear flank, and that will give you a noise. So that is normal, and it is plain flat it is made, because we want to allow that, because we don't want any strain to produce on your crankshaft, and that makes you some noise. And it happens for the Sulzar. because Sulzer and the Mitsubishi. Now the dog sport is no more, so we'll not go into dog sport. Man BMW, we do use the chain drive. And intelligent engine, we don't have the cam, but there is a cam which is driving the fuel pump. And the pumps that is close to the crankshaft, and we use the gear drive. We don't use the chain drive. Usually it is the gear drive, and BMW uses the gear drive. And we have seen this is advantage and disadvantage. We have covered that if you put the camshaft at lower level, hydraulic pipe length will be high. This portion is already been covered. The advantage of disadvantage of putting the camshaft at higher level or the lower level. BMW put it at higher level because your fuel pump is on the cylinder head platform, whereas the Sulzer, they put it at the bottom side. It means it is a lower level fuel pump platform, and camshaft level is low. And chain, how is the construction of the chain? The construction of the chain, if you see, it means the chain has got the pin link. Pin link means the outer link. This is the outer link, and it has got a hole here. So this is outer link, and this is called pin link. It means one will be in this side, one will be in this side. And there will be a hole for the pin. So to each side, there will be pin link, and this pin will be interference fit, and it will be riveted. It means one side will be the soft, another side will be the hard, and the soft side we hammer it and we make it riveted. Now inside what you have, that is this is the outer link. We have the roller link. It means you have another link here. Also it will be both side to this side also there will be one, and this side two. So this two link is the roller link, because this two link, what I have drawn just now, this two link will be having a there will be a bush. So there will be hole, and on top of this hole, there it will contain a bush. And this bush will extend to it will be attached to this two hole. And this bush also interference fit, or pin also interference pin. And this pin diameter is the less than the bush has got internal diameter and the external diameter. Our pin diameter will be less than the internal diameter of the bush. Suppose we have this is the bush. This is the internal diameter. So there will be, pin will be less than this diameter. So we have the bush, which is fitted, interference fit with the link plate. This is the roller plate or the inner plate. And this pin will pass through this hole. And then there are two outer link or the pin link, and this pin will be interference fit with the outer link. And this bush, we have now this bush is fitted in between this, and this gap there will be a roller. It means there will be a roller on top of the bush. And this roller is free to turn. So what does it mean when the chain link is moving in this direction? Pin also will move. There will not be any relative motion between the pin and the outer link. Similarly, This bush is interference fit with this link, inner link. So when there is a motion in this direction, there will not be any relative motion between the bush and our inner link because it is interference fit. But there will be a relative motion between the roller and the bush as well as the pin and the inner surface of the bush. So this, because roller is turning, so there will be a clearance between the outer surface of the bush and the inner surface of the roller. And the pin is moving with the outer link, whereas bush is moving with the inner link. So there will be a relative motion between this. So the inner surface of the bush and the outer surface of the pin. So this is the way it is arranged, and roller should be free to rotate and on the push. Now this is always press fit or the interference fit. So that what is the advantage of having the interference fit? So their load will be less. It means there will not be cyclic loading here. So it will move together. There will not be any motion between this pin and the outer link and the push and the inner link. And then the pin is reverted. Riveting is done. So this is the one side. And this side will be the soft. So after putting this pin, you can rivet it by hammering and it will become like this. And then we keep on adding the link, it become endless. It means we can keep on increasing the length of our chain. Now for the reversible engine, we have a requirement, that is we cannot have a patent end link. It means it will be somewhere, it will end and then end will be connected, but it has to be riveted connected. Similar way, exactly what we have. We cannot have a patented link, means end link. What does it mean? Suppose there is a bicycle, we use the chain, but that bicycle chain, if you want to remove, we don't have to break this pin, this link. They have a different type of arrangement. They can, that is removable, and again they reuse it. But in our case, we have to have riveted. It means once you remove it, then that same pin cannot be used. Again, you'll have to use a new link. It is a requirement. And the pitch of the link, it means the pitch is like here, this is the center point, this is the center point. Here you have a roller, here you have a roller. This distance is called pitch. So the pitch of the chain. And pitch is usually, it is 50 millimeter to 110 millimeter we do use. And this chain, it can be double, it can be single. This, what I had drawn is single. And double also, it can be like pin length. If you extend and you put another link here, so it will become double. This is one roller, this is another roller we can accommodate. So depending on the load, if the load of the engine is high, we can go, some engine you will see there is double and some engine is single, depending on the load of the, how much load it's coming on the chain. It means the torque is required, how much torque is required. Now this chain should not break. That is the reason chain, the factor of safety is very, very high. Factor of safety is chain is kept around 25. What does it mean? Chain is tested for the tensile strength. So it will be taken in the workshop, testing workshop authorized, that it is tensile force is applied, and then we check at what force it breaks. So that is the tensile strength we can calculate. And there will be a maximum working load. And this maximum working load will be your, suppose maximum working load is X and tensile strength is, we have got Y. So definitely the X will be less than Y. But X and Y, there will be a relation that should be what we use. It is 20 divided by 25. It means the tensile strength what we have divided by 25, that will be the maximum working load should come on the chain. So factor of safety kept very, very high so that it does not fail. Now the chain drive, if it is engine is 7-cylinder, we keep it at the end. At the end, we have the chain drive. But if it is a number of cylinder is more, 8 to 12, what we do, we keep it at the middle position. You'll see the chain drive is at the middle position. Why? If the shaft is long, then what will happen? Your this will be the torsion will be, it means the torsional stress means that is the displacement. If we see this end, it is a, for an example, it is a circle. So there will be a torsional displacement. We have seen in this crankshaft chapter. So this torsional displacement will be very high. Suppose one end you are driving, so other end it will be very high. So instead of that, what we do, we put it at the center, so that torsional stress will be reduced. So that is the way it is arranged for the larger engine, because twisting will be. And another thing, the chain drive we have seen, there will be a stretch because chain is always stretching. It means there will be a bending moment on the shaft also. Whereas gear drive, that is not there, because gear, there is no stretch like chain. If you have the chain, it has got a stretch. Whereas gear drive, it will have a tangential force. And we use the involute profile so that the force is applied at the common tangent. Now, roller chain, it is got advantages because it is light and flexible. It means slight misalignment it can take, whereas gear drive, we have seen that it rubs, as well as if gear misalignment, the load distribution can change and it can damage your gear. So in this case, the chain drive, that is the advantage, it is light and friction is very, very less compared to the gear drive. And we depending on the, it means the speed, we can adjust the gear teeth, sprocket teeth, so we can have the direction, as well as the speed we can achieve. So what is the chain has to be very strong because it should not break, though it is lighter, so it should be strong enough to withstand that load. So that's why nickel, chromium, and molybdenum, like this alloying element, we have already covered in the general, that metallurgy and the chapter. So we know this is the what are the advantage and how the property has changed, so that the chain manufacturer, they use this nickel, it become hard, tough, as well as the hardness is high, so that the surface hardness is high, so that it does not develop crack or break, because it has to withstand very high load, as well as it should not deform. So because, and as well as there should not be a wear resistance, it should be, it means wear should be, there will be wear, but very, very negligible wear it should last for the long life of the engine. But the chain drive, it is around 15 years is the life. So this, if you see this, the drawing I have drawn, it is exactly the same. This is the inner plate, this is the outer plate. So inner plate is, and the roller plate is same, roller link. And outer plate and the pin link is the same. This is the roller. So if you see, this is the roller, this is the cutaway section. So inside what you have is the bushing. So roller and the bush, there is a clearance because roller can rotate. And bush, how it is fitted? Bush is fitted on the inner plate. Both sides, it is interference fit. So that when there is a movement of the roller means the roller free to move, but the inner plate, when there is a axial means that there is a angular displacement, that time the bush also will turn at the same angle. So there is no rubbing action between the bush and the inner plate. Similarly, pin is fitted in the outer plate, that is also interference fit, and on one side, other side it is riveted. So if we want to remove or the put, we put it from this side, other side we rivet it. And we can knock out that rivet, grind out, and then we can push it from that side, it will come from this side. And this is the pin. So this is the pin, this is our bush, this is our roller. And the roller will fit in between two inner plate, and there will be some clearance because roller is free to turn. So this is the arrangement of the pin. Is everybody clear about the arrangement of the pin? Any doubt? All of you clear about the arrangement of the pin, by the link of the chain, pin, bush, roller?
It's clear for me.
Yeah, Zephaniah, tell me.
Okay, thank you, Chief. So, where is exactly the friction happening between the roller and the bush?
Say again. What did you say?
The friction when the chain
Yeah.
is rotating, the friction is happening between the bush and the roller.
So there will be a friction. That's the reason it gets elongated. One, inner surface of the bush and the pin, because there is a relative motion. Another, outer surface of the bush and the inner surface of the roller, because there is your roller is free to rotate, and this is fixed. So there will be a relative motion. Another is outer surface of the roller and the sprocket. Because if you see the sprocket, this is your sprocket, this is the roller. So this roller outer surface and the sprocket, there will be friction. And roller is rotating.
Okay,
The
Chief.
roller and this, and bush and the pin. These three places, there will be, it will be weighed down. Clear, understood?
Yes, Chief. Thank you.
Yeah. Test found. Teka, tell me.
Sir, the bush and the pin link, is there any relative motion between them? I think there is no relative motion, yeah?
Bush and
Between
the?
the pin link.
Yeah, bush and the pin, there is relative motion. For an example, when it is engaging into the sprocket, this is the outer link, okay? And our pin is interference fit with the outer link. And this is the inner link. This will not be a straight line. So this angular displacement of this and angular displacement of this will be different. So there will be pin is interference fit with the outer link, whereas bush is interference fit with the inner link. If there is a different angular displacement between the outer link and the inner link, the pin and the bush, there will be a relative motion or not? Have you understood, Teka? Suppose this is the pin, this is the outer link, and this is, it was initially in this position, it was straight line. Now it is different. So this is the inner link, and this is the angle for the inner link. Then what will happen? Inner link has got the bush, outer link has the pin. So pin is same angle with the outer link, and bush is same angle with the inner link. So will there be any relative motion between the pin surface and the inner surface of the bush? Can you visualize, Teka?
I can visualize it. I think you are saying that the inner link is the same with the busha rotating together.
Yes, inner
The outer,
link,
the outer.
yeah, bush is interference field.
Okay, now so now it's clear, sir. Thank you.
So let us, this is the arrangement of the link. Now, as we have seen, the factor of safety is 25 we keep so that it prevents the stretching, because the link will stretch otherwise, which we don't want. So that's the reason tensile stress is calculated, and the maximum working load, it is calculated, and it will be tensile strength divided by 25. But it will get, due to this tension, what will happen, the wear down will take place. As I just explained, these are the place where you'll be having the wear down: pin and the bushing and the roller and the sprocket. These three places will be having the wear down. And due to this wear down, what will happen, the chain will extend, length will extend. And once we have the length is extended, your timing will be retarded. That is the problem. And tension, how much tension you'll be giving to the, there is a limit, how much tension we do give. Tension is half, minimum is half chain link, and maximum is one chain link. It means we have a camshaft, this is the crankshaft. We have the chain. I'm not drawing the idler. So suppose this is the one idler, let me draw. This is one idler, or the jockey wheel, which is the tensioner. Now, this side, if we bring all the slack in this side, which direction will be rotating in that case? It means it has to move this chain in this direction. Then all the slack will come into this. And after that, this chain will have to push it in this transversely, port and starboard. And once we push it, it should be this distance we must get minimum half link and maximum one chain link, because we have the measurement of the chain link. So this is the way we do check the chain tensioning. If it is suppose more than this, then what will happen? We'll have to tighten. And if it is less than that, we'll have to slacken so that it remain in this values, that what is given by the makers. So usually what will happen, it will increase because of this stretch and the wear down, and then you'll have to tighten. So we'll see how do we tight, but we check the tensioning of the chain by moving this, and it can be moved by hand. Once you bring the slack on this side, you can push it by the hand, and then we can get this value, and we can measure, we can check if it is within the limit or not. So now if it gets elongated, because it will get elongated, the chain, so then there is a measurement. It means how much it has got elongated. So we check that if it is 1%, it has reached, then it has to be renewed, or there is some link we can remove. That 2 link maximum we can remove. So this has to be, because once the stretch is around 2%, around 1%, then your timing will be out. So which will affect, adverse effect on your engine operation. So we need to either we remove the link, 2 link is allowed maximum, and or we need to renew the chain. So depending on the how you correct it. But when you do that, that time you'll have to adjust the timing. We'll see how we adjust the timing also, because timing has to be corrected so that fuel pump and exhaust valve, it will get retarded because of this elongation. So that has to be corrected. So idler wheel, what we have, that I have drawn in last when I had drawn, there will be one of the jockey wheel. The jockey wheel, why we have that, which gives the support to the unsupported chain length. And one of the jockey wheel, the center point has to be adjustable. It means center point is movable. So that is the, like we have the jockey wheel, suppose, which is giving the support unsupported. Suppose our camshaft is here, crankshaft is here. So this is the unsupported length, this length. So we have put one jockey wheel here. That side also we can put the wheel, or we put the bar, guide bar, so that it gets support. And this has got a center point. This center point should be movable, one of the jockey wheel, by which we actually adjust the tensioning of the chain. And it is a requirement. Otherwise, you won't be able to adjust. Now, let us see this diagram. It will be clear to you how we do. So here we have the two intermediate wheel. This is one of the jockey wheel which is adjustable, the center point. So this is pivoted here. And if we tighten this, if you move this in this direction and in this direction, what will happen? Once you are moving downward direction, this will move to this direction. So the chain will get, tension will increase. And if we move in this direction, then what will happen? This will move this way, chain will get slackened. The tension of the chain we can adjust. Now this is the arrangement. This is the latest arrangement of the chain tensioning. We can have without this arrangement, but there is some purpose of it why we have this arrangement. In this case, what we'll have, so suppose we have this is more than the required. We need to tighten. So what we do, first we slacken this one. Then we slacken this. And this, then we slacken. It means we'll be removing the lock washer and then slacken. After that, we slacken this one. Once we slacken this, what will happen to the spring? Spring was under compression. It had a length. Now, once you are slackening this, the spring length will keep on increasing. How much will slacken? This will keep on increasing till you have a free length of the spring. What is the free length? There is no load on the spring. Spring is free from the compressive load, because when you have tightened, we have given the compressive load. Now, this one we have slackened this nut. We have measured the free length. We'll get a length. This is free length. We get a measurement. After that, what we do, we have slackened. There is a gap on top because we have slackened. And now bottom also we have slackened both. And we have slackened this nut up to the free length of the spring. And we have measured and we have got a value. Now what we'll do, we'll start tightening this. Once we are tightening this, what will happen? The spring will get compressed. And because of that, there will be a force in this direction. It means we are moving this in the downward direction. When we had slackened, it has moved up. Now we are tightening. Once we are tightening, it means this is moving downward. And it is this point is moving, this is movable point in this direction. This is fixed point. This is the fulcrum point. But when we are tightening, that time we must turn this. In which way will be turning? It means, and before starting this exercise, like for checking this tightness, tension, we had to turn this in this direction. Move the chain in this direction so that all the slack come to this side. But when you are doing this exercise, tensioning, that time we need to move in this direction. Why? Because our jockey wheel, which is the tensioner, is on this side, slack has to come to this side. So we'll move in this direction so that all the slack will come to this side. And once you're tightening this, it is getting compressed. That time we'll have to keep on turning by the turning gear, the crankshaft. Engine has to be turned so that all the slack will come to this side. It has to pass through this so that the tension, when you are doing the tension, the slack has to come to this side. So you keep on tightening. Now how much you will tight? So in this case, this arrangement, you keep tightening to a length, for an example, that is the final length on the after compression. This is the length. Now, what is the free length will be higher than this length because this is under compression. There will be a value of this. This value will be given how much is the difference in the spring. There will be a plate. It will be with the Jubilee clip. It is tied up. So it will be written there what is the free length and what was the after compression when ship was delivered, engine was delivered in the ship, it is there. So this will be the after the compression, this length is given, this length is given, as well as what is the difference of the length that is given. That is the initial value. Now what will happen? During the operation, your spring length will reduce because it is already under the compression. So we have seen in meteorology that if you keep under force, at some there will be relaxation of stress, and that because of that we will be having the free length reduced. Now what we have measured here, the free length is reduced. Now, what then the value will be maintaining? We'll be maintaining the initial LF and minus initial compressed length. That difference will be maintained. What does it mean? Suppose our length was 189 for an example. That is the free length, millimeter. And after compression, when the ship, this engine was delivered, then this is suppose 170 millimeter. So what is the difference? 19. Now we have a value of LF which is less than this 188 for an example because of the it is under compression, the length, free length is reduced. Now, what will be the LC? We are tightening and we are measuring what is the LC because the difference has to be 19. In that case, LC will be 169. So when you are tightening, this should be difference. So that's why free length has to be measured because free length will not remain fixed. It's not necessary. It might change. And we need to deduct this value which is given initially, and that length will have to, after compression, it should reach to that length. And then during that tightening, we'll have to keep on turning this so that in this direction or the slack will come and it will get tightened. Once it get tightened, after that you stop. You have reached to 169 because you have achieved this value, and that gives the tension on the chain. You will achieve the one link, the half link and the one link in between. After that, what you do, you stop tightening this. After that, you start tightening this one. Once you start tightening, be careful, the spring length should not be reduced. It should maintain that spring length because we have already tightened this. Now, how long you will be tightening? Once just touch the surface of the pin. This pin surface, which is forward and aft is placed, this pin, it will touch the surface, you stopped it. So that the spring force, what we have given 19 is maintained because the difference of length, that is the force, it will convert into force. After that, you tighten this, lock it, top side. Once the top side is locked, after that, we'll have to tighten. It means when we have tightened it and achieved this length, that time you see there is a sleeve here. This sleeve and this, the spring carrier, there will be a gap, clearance. It means suppose we have the sleeve and this is the spring carrier and we have the spring on the side and we have the tighten the nut here. This is the nut. This nut, when we have this spring length we have achieved, that time there will be a clearance here. This will be the clearance. Now top side we have already locked it. The bottom side, what you do, we now start tightening so that this bearing carrier, means the spring carrier will touch the sleeve. So now your this length will reduce. But tell me now this length has reduced. Will it affect the chain tensioning? Who wants to answer? Have you got my question?
Yes.
Initially, we have tightened till 169 millimeter. We have got 19 millimeter difference. Now, after tightening top two nuts, we locked it. It is on the surface, on the pin. Bottom nut, we are tightening. When we are tightening, because the spring length will reduce, because this clearance, we are moving this clearance upward direction so that it touches the sleeve. Now the compressed length is different. It will be less than that. It means there will be a force. That force, will it affect this side? Because we have on the jockey wheel, which is the tensioner, will there be an effect on this? So, okay, let me answer to that. There will not be any effect to this. Why? Because we have already tightened this. Since we have tightened this, we are tightening this, but it will not move downward direction because it is locked here. It has already touched the surface. So after that, when we have tightened it, it has touched here. After that, we tighten 40, around 40-degree angle. After normal hand tightening, after that we move 45-degree for tightening. After that, we lock it by the lock nut and the washer, that is the tab washer, we lock it. So this is the way. And after that, we check the tensioning here. When we are checking the tensioning, it has to move in this direction. So after securing everything, after that we can check it. So that is the way we do the tensioning of the chain. And this is developed because it will avoid the over tightening of the chain. Suppose we don't have this arrangement, still we can tighten. There is no problem. So we slacken this and this knot will be here. So we slacken this, then you keep tightening the bottom knot and it will move downward and tension will be there. But this difference ensure how much tension you are giving. As per the maker, this much tension, chain should get this much tension only. So this value we keep always constant. Is it clear how the chain tensioning is done?
Yeah, it is clear, Chief. Clear for me.
Okay. So let's move on to the next slide. So this is the way we do the adjustment. And now if suppose we need to
Sorry, Chef.
uh, yeah, Sophanis, tell me.
Okay, thank you. When you say when we are slacking the tensioner, you said we have to bring the slack to the other side. I don't understand why we bring
Yeah.
it to the other side. We need to bring it as the same as like tensioning. We want to make it loose from this side so that we can easily slack.
No. When you have checked the tightness, you brought the slack on this side. Then you can push it. If it is under tension, will it give you slackness? It means will you be able to move? It will not move because slack is on this side. So for checking the tensioning, we need to bring in this direction. But when you are tightening, it means this has to move this direction. It means this should be under tension, this side slack should be. Once this slack is here, then only you will be able to move. Because why you are tensioning? Because of the slack. Slack is higher than the required. That's why you are tensioning. If there is no slack here, then how will you tighten? How will you move this? It will not move because slack is somewhere here. Maybe here slack is. But we are tightening here to increase the tension. Slack is more means the tension is less. So that's why in that case, transfer the slack to here, just rotate in opposite direction. In this direction, if you rotate, then what will happen? This will be under tension because this is the driving and this is the driven. So once this will be under tension and slack will come to this side. Because this will be the force which will be turning the camshaft. And this is the force which will actually pulling your chain. So slack has to be here so that we can tighten this. You are tightening because slack is more. If slack is maintained, we don't have to tighten. Is it clear, Sophonias?
Yes, Jeff. What I heard was something else. That's why I was confused.
Okay,
I thought you said for releasing the nuts, but you said for checking. So for checking, yeah, we need to bring it to this
No,
side.
can you be a bit louder?
No, I understand, Jeff. Okay.
No, I couldn't follow you what you said. That's why. Can you speak a bit louder?
Yeah, what I was hearing from you was for releasing the nuts before tightening. For releasing the nuts, I thought you said we need to bring the slack to the right side.
Yeah.
But
So
you said
what
only
what
for
I
checking,
said,
not for releasing.
yeah. Before doing anything, you can bring the slack to this side. Even when that can be done after, and before also you can do. And during the tightening also you'll have to keep on rotating. So all the slack passes through this and it gets tightened.
Yeah.
Both way you can do. But definitely when you are tightening, that time you'll have to keep on turning. So this is the way tightening is done. Now, if we need to remove maximum two link, it is allowed to remove. In that case, we'll have to break the link and remove the two link. And so the two link, it is allowed to remove, and then we can shorten the length of the chain if it is stretched. The length has increased. So how we do that then? So, but when we do that, we make sure that we have the new link, new pin. Because same pin we should not use once it is used for riveting. And after tightening, once you, for an example, we remove two chain link and then we assemble it. After that, we need to check the timing. When you check the timing, you will see the engine maker will give a reference to one of the cylinder at TDC. Usually it is #1 cylinder at TDC you keep, and there are some pin gauge by which we can check the timing. It means if you see the engine, okay, so there will be the pin gauge we have. For an example, first it has told you that for an example, the manual has said that the number 1 unit is at TDC. It means you'll be checking the flywheel, the number 1 unit is at TDC. After that, but it is not enough. On that unit, it means we have a pin gauge. By the pin gauge, we'll have to check. This is our A-frame. On the A-frame, there will be a punch mark. And then on the wave, because if A-frame is, this side is 4, so this the pin gauge, like this is the A-frame. On the A-frame, there will be a punch mark, and there will be wave. And on the wave, at that position, on the top, there will be a punch mark. And there will be a pin gauge. It will be like this. So this point will be here. And this point will be here. And all the toolbox you'll see, each ship has got this, and that is the ship specific. So this pin gauge we put, so it has to match this two punch. So we ensure that yes, this engine, this unit, number 1 unit is in TDC. Otherwise, we have flywheel marking, but that is not accurate marking. So we need to check exact TDC position. After that, we have the camshaft, and camshaft will be having a punch mark at the bottom. And then there will be another pin gauge will be having, suppose this is the, for an example, this is the cam case. So this pin gauge, one punch is here, another punch is here. This punch mark can be different place also, but it will give you the manufacturer where the punch mark is. So this pin gauge will say, tell so can you hear me? Because it's internet is coming and going. That's the reason it is happening. Teka, can you hear me?
Sir, now is
Oh,
okay,
Chief.
but the previous one
Now
is
it's okay.
okay.
Yeah, because it is coming and going. That's the reason it is happening today. So
We didn't hear
the
anything, Chief.
cam
It's tensioning.
shaft at the bottom, you will see there is a punch mark, and on the cam case there is a punch mark. So this pin gauge also it has to match. So we have the reference is the number 1 unit at TDC, and then where this punch mark is, it matches between the camshaft and the interplacer or in the cam case, then it is in correct timing. But if the timing is different, then what will happen? This will not match. It means suppose the punch is here, but your pin gauge is in contact with the camshaft here. It means this much is difference of angle, and then this much has to correct it. So we'll see how we correct it also. That's the way timing is checked. And all the makers will give one of the unit, usually for a number 1 unit it's TDC, that is the reference, so that you can measure it. But other pin gauge also will be having, that is for the lubricator. for the distributor. So there also you'll be having the similar type of pin gauge. It will be written, number will be written, which one is for what. And yeah, Sophonius, tell me. Yeah, Sophonius, you raise your hand. Sophonius, do you want to say something? So the chain also to be lubricated, exactly same like the gear. There is a spray nozzle through which the oil is spraying onto the chain, and when it is moving towards the sprocket, before that the spray is there so that it can carry that oil on the surface, and when it is in contact with the sprocket, then the elasto-hydrodynamic lubrication takes place, and there will not be, the moment it is elasto-hydrodynamic, like hydrodynamic we use, it is full film lubrication. There will not be any metal to metal contact in between. There will be full film of lube oil. So that also, that gives, yeah, Sophonius, tell me. Sophonius, you raise your hand. I can't hear you. You'll have to unmute. Your speaker microphone is mute. Sophonius, your microphone is mute. You unmute it and then speak. So let us continue, and then Sophonius will come up with the question. I'll answer to that. So the lubrication, it gives you cushioning effect also, because it can, lube oil has got the absorption power, vibration, it means dumping effect. So the vibration, it gets converted into heat energy. So maintenance of the chain, the wear of the chain we must check. So that elongation length we check, we can check the wear down, and visual inspection has to be done. The bearing has to be checked, and the sprocket where there is a profile gauge by which we can check. This is the sprocket, and there is a profile gauge. We can check the clearance. With the filler gauge, this clearance can be taken. And also if there is a mandrel provided with the sprocket. So this is the sprocket, and there will be a mandrel. And this mandrel will give you it will make a smoothen of the surface of your sprocket wheel. This is also provided by the manufacturer. Do not use any other mandrel. It is given for the engine specific purpose, and this is, the application is only for this sprocket. So then free chain roller freeness we check if it is seized or not, and each and every roller has to be checked. Alignment of the sprocket has to be checked. Yeah, Sophonius. Okay. Still it is broken, because is it broken still? Or is it okay, the voice? Or still broken?
Chief,
Yeah.
Chief, we cannot
still
hear you.
broken today.
After Sophie questions, we didn't listen anything, almost.
Yeah, because this internet today is having problem. Other day we did not have this kind of problem. So,
I think today is holiday. That's why, Chief.
okay.
Chief, could you repeat about the punch marks? I didn't hear anything about the punch marks. Which punch marks we are talking?
Okay. Can you hear me now?
Now it's okay, Chief.
Now it's better,
Yes, we
Chief. It's
can
okay.
hear. Now it's better, yeah.
So the punch mark, what I said, you bring the number 1 TDC number 1 unit to TTC. Then there will be a position of your wave, crank wave, and there will be a punch mark on the top of the crank wave. And that punch mark, you can put a pin gauge, and then there will be pin gauge will be like this. So this is one point, this is another point. This will be on the top of the crank wave, and this is on the A-frame. So exactly at TDC it will match, otherwise it will not match. This is the pin gauge. It is, there is no flexibility, it is strong, hard. So it has to be, it means you'll have to turn it, the engine to exactly TDC, it will match, means that is the TDC position. And the camshaft, this is the camshaft. At the bottom there will be a punch mark, and there will be on the casing there will be another punch mark. So it has to match. If the timing is not correct, this will not match. It means, for an example, this is the punch mark. So this much angle, it is out. Understood? Is it clear to you, this punch mark?
No, Chief. Still, you was out, so we didn't hear you anything, Chief.
So, Chief, this punch mark is on the flywheel and on the cam itself. Or
no flywheel. This is punch. This punch mark is on the A-frame and crank wave of number 1 unit. Crank wave top and your A-frame inside. Unit is inside, isn't it? Flywheel is outside. Initially, we check the flywheel, that marking, and we check if it is matched with your angle or not. But that is not enough. You'll have to check by the pin gauge. And there will be one pin gauge here, another pin gauge is for your camshaft. Is it clear? Understood?
Okay.
And then we know if your timing is correct or not.
For me, it's clear.
If it is not correct, then you'll have to correct it. This is the pin gauge I talked about. Can everybody, means, are you having problem, all of you or some of you? The hearing problem.
I have problems.
Chief, no, all of us, because your connection is a little bit weak.
Yeah, because maybe because today there is connection, it's coming and going. Usually it does not happen. Today it is happening. And that is the internet connection.
Now in this moment it's okay.
Okay. So then the maintenance. Maintenance is what you do for the maintenance. Here, so let us see this slide, the maintenance, the wear of the chain, that elongation we check, the sprocket teeth we check, and the wheel bearing, if it is worn out, then the sprocket will drop. That will give us how we check center to center distance. If we check, then we know the bearing is worn out, it has dropped. And then freeness of the chain roller, that has to be checked. Alignment of the sprocket, alignment, how we can check? We can take a scale. Suppose this is a one sprocket and another sprocket is this. Or the piano wire, with that also we can check. So this has to, suppose we put a piano wire with the weight, then what will happen? If there is a clearance here, but there is no clearance here, you can check if it is aligned or not. Alignment can be checked. So the sprocket bearing we have seen, that has to be checked, and then examine the possible fatigue crack. That is the, you must check the surface of the sprocket if there is any crack developed. And we have seen that because it is subjected to the cyclic loading, that's why it will be the crack, type of crack it will generate. You know that there will not be any neck formation, and once you suspect a crack, you can go for die check because it is a surface check, surface crack. So we'll find out that if yes, it is a crack, and once it is a crack, you'll have to change the sprocket. So that's the way the maintenance, periodical maintenance should be done. And this sprocket wheel, we will examine another thing. There is a gauge. What I was talking about, it means you have the sprocket wheel and there will be a gauge. And with this gauge, suppose we take this portion. So it will be like this. And then it will be like this. So this gauge, we put it here. And once you put this gauge, this is nothing like a straight rectangular plate. And this clearance we measure. And this clearance is given by our manufacturer. So by the profile gauge, we can check how much will be the clearance between the sprocket and that profile gauge. So this is the way the measurement is done. So this clearance is given, and all the manufacturing manual gives you, for an example, it is about 3.5 millimeter, but it depends upon the size of the sprocket. And if it is excessive, the elongation, then you'll have to check, you'll have to renew it. And another thing, what is the problem if it is elongated? Tension, if it is excessive, then there will be stretch is high. And if it is slack, then the shock load will be very high. It means, what is the problem with the shock load means, when the pin is like the roller is engaged, that time the load increases. When it is disengaged coming out, the load is become reduced. And so there is no load actually, only the mass. So the tension is high. So your excessive tension means the load will be high. If slack, the cyclic load will be high. Because once it is coming out from the sprocket, there is no load. Once it enter into the sprocket, there is load. If it is slack mode, the shock load will increase and the fatigue failure will happen. That's why we need to keep the tension, correct tension as per the manufacturer. So in the chain drive, we have the other drive, which is, this is the sprocket. In this particular case, it is the duplex chain wheel. And these are the drives we use for the governor lubricator drive. And these are the bearing, which is the roller bearing, and oil is supplied from here for the lubrication. So this drives is from the same, from the sprocket. At the side, we have the sprocket for driving the governor as well as the lubricator. Then your the distributor, all these drives coming from here. And the shaft is supported by your bearing, that is the roller bearing we do use for that. And lubrication we have seen, it is coming from the engine lubrication only. So this is the arrangement. When we break it, we can see this arrangement. This is the bush, this is the pin, and this is the roller. These are the inner plate, and this is the outer link. So, and this is the pitch. It is the simplified diagram of a roller. It is the same thing what I had explained, exactly the same. So this is the component of the link of the chain. Now there is the plate has to be very strong. What we do, you'll see the plates, if you feel, put your finger, you'll feel it is rough surface. What is that roughness? It is kept intentionally. And this has to be very strong. That's the reason chrome molybdenum steel we do use, and nickel chrome molybdenum steel, so that it becomes hard and strong, very strong. It does not deform, elongate, stretched. So this is the material we do use for the link plate, and link plate is pinned. What do you mean by pinned? That's why when you put your finger on the surface, you will see it is rough surface. What does it mean? So this is the surface, and we make it small dent. Actually, rough surface means there are uneven surface. We use the ball, very hard ball. With the velocity we hit on the plate. Once it is hit on the plate, then what will happen? It will become a dent. Small dent will happen. We give it intentionally. Once you have a dent, then what will happen? There will be energy. There will be a compressive force in this area. As we know, the compressive force is prevent the opening of the material, whereas the tensile force is crack will develop. So we keep the surface under compression. That's why that is called pinning. Intentionally it is done. We don't make it smooth, so that the fatigue failure does not happen. Fatigue strength increases because of this pinning, because local, we add some energy. That is the compressive energy we add. That is the reason pinning has been done. And reversible engine, as I told you, all the end link cannot be a patent one. It has to be a riveted one. Like the other link has been connected. Now the stress, there will be stress on the chain. So there will be a crankshaft sprocket also. There will be a stretch because of the chain, because gear drive, that stretch is not there. And there will be cyclic also, because cyclic load, because sometime it will be, load will reduce, sometime will be increased. And the factor of safety, we have seen that we keep it high. Yeah, any you tell me. Any you raise your hand. Your microphone is off. You put on the microphone and then speak. Yeah, now you speak.
Chief, your voice is breaking now in the Zen. I'm not following. I think it's same for everybody.
There is some problem then.
Chief, today is holiday because people are using internet. It's busy, you know. That's why a problem is.
Okay, that may be one of the, yeah, it does not happen actually. Usually this today is happening. What you're saying, maybe that may be the reason.
Because we are not following, you know, since already 20 minutes past. We are just looking the slide.
Okay, means you cannot hear my voice. So in that case, what do we do? I mean, what we can do, we can complete the lecture, and because we are, I'm sending the video recording to you all, so you'll be able to connect it. And if you have still some doubt, you can always contact me. I'll explain to you. Will it be okay? Because
Okay,
the
sir.
normal
Okay.
practice, the way we are doing, we are sending
Okay,
you
Chief.
the
Okay.
video recording, because all the lectures are recorded. So, Haile Michael, you want to say something? So let us complete another 40 minutes is there. So the stretch and there can be vibration on the at the critical speed, resonance will happen, and there will be vibration of the chain, and which we don't want. But during the critical speed, it will be. That's why we have that, because of the vibration. We keep the FOS, that is the factor of safety, is high. And another thing, to reduce the vibration, we use the balance forces for the first and second order moment. We balance it. So So we do the balancing of first and second order moment. Let us see what is that. So how we do the balancing that, okay, before we go to the balancing, let us see another effect. It's that polygon effect for the chain drive, which you don't have for the belt drive and the gear drive. What is the polygon effect? That polygon effect is our uh, velocity of the linear velocity of the chain changes. It means if we see this, this is the sprocket, and we have the, for an example, we have the four sprocket. One is here, one is here, one is here, and we have the chain is entering from here. This is the, and it is going to this direction. Now, what is happening? There will be a velocity here. And this velocity at which it is moving in this direction will change. It will not remain same. Why it will not remain same? So this is the, suppose the sprocket. And then this roller will move to this position next. So what will happen? Because of that, now our chain is at this position. So this was the center point. This, so this was the angle. Now what will happen? This angle will change now. This will be, for an example, gamma by 2. And because of this angle change, what will happen? This will be V max, and this will be V minimum. In this direction. So since there is a maximum velocity and the minimum velocity, there will be an acceleration. It means when, in this case, this was here maximum speed and it is shifted here, this has come to this position. So the velocity has reduced. It means the velocity as it has decelerated. But next moment, what will happen? So this roller will come to this position like this. Then the velocity will increase from this to this. Then there will be an acceleration. Because of this acceleration and deceleration, there will be a jerky movement of the chain. So that is also an adverse effect for our chain drive. So we need to avoid that. How do we, that is called polygon effect. How do we avoid that? We can, here we can see this is the maximum velocity at this point. And at this point, because R has reduced and angle also has changed. And because of that, this will be our minimum velocity. And there will be acceleration and deceleration, which can be handled. We have an experimental data by which we can see if we keep the number of teeth 17 to 23, then our the jerky motion will reduce. That is the difference between the minimum and maximum speed, that is will reduce, and the jerk also will reduce. For an example, suppose the velocity difference variation in percentage is this side, and then we keep the number of teeth on this side. So in that case, what will happen? This curve moves like this. And this one, if we see that, it will be around 17 to 23 will have the reduced variation of speed, so that the variation, that is jerky moment, we can reduce. So we always keep around this number of teeth because of that. Is it clear, understood? The how we deal with the polygon effect. So this is the way we reduce the polygon effect. And the acceleration also, actually, the how many number, if we go for the minimum number, the acceleration will be high. If we go for the increase the number, acceleration will be reduced. So at one point we have seen 17 to 23, we keep that number so that it affects, polygon effect is reduced minimum. And another thing what we do, we have the jockey wheel. So we, and the distance, center to center distance, we keep multiply of the chain link. Suppose we are chain link is X. So we have put a multiplying factor of Y multiplied by X. So we give the distance from center to center distance, we keep it like this. So that what happened, so that when it is moving in this direction, both moves at the same time. So the polygon effect is reduced. So that is another way we deal with this polygon effect. So the chain lubrication we have seen already, spray form, we give it to the chain lubrication. Now the elongation, how do you check? The elongation, we measure the length of the chain. The length of the chain we measure, and we take the 10 link and we measure 10 link, we can calculate by multiplying 10 multiplied by the pitch. That will give you the length of the 10 link, and then we can find out how much percentage is the elongated, because the measured value we can calculate. And then percentage, if it is 1%, then it means we'll have to remove the chain link, or if it is more than that, we'll have to discard, we'll have to replace the chain. So this is the way we measure. Manual will show you from which point to which point you'll be measuring. So in this case, if you see from this point to this point, and we consider it as a 10 chain link, and 10 multiplied by the pitch, that will be the original length, and the measured value is this. So we can calculate how much percentage it has increased. It means if you see this formula, we can measured length multiplied by the pitch, number of pitch, divided by the pitch multiplied by the uh, uh, number of pitch, that is the measured length minus this number of pitch and multiplied by the pitch, that is the difference, divided by this multiplied by 100. So we can get the how much is the value. So if you see this, for an example, this is the example, 10 chain link calculated is this and measured value is this. We can find out how much is the percentage of elongation by using this formula, and we can do it that way. And then we can judge whether to link to be removed or it has to be replaced. So when you measure, how do you measure? We bring the slack to this side because we can get the maximum chain link. And then once you bring it and we push it, we get the we measure the length, and when we measure the length, that time it should be in stretched condition. So this slack will be on the other side, so that is the stretch condition. We measure the link. When you checking the tension, slack should be this side. When you measure the length, it has to be stretched. And then 10 link we measure. Because of this side, we get the maximum number of link accessible. So then we measured value we know the original value, we can calculate that. So that is the way we do. Now, how will we replace the chain link? It means we'll have to replace the chain link. If it is 1% it is reached, then what will happen? It will be timing will be changed by retarded by 2 degrees. We'll have to correct it. That's why we remove the chain link. 2 chain link we remove in this condition. Once we remove the 2 chain link, then what will happen? Suppose we have removed from this side. Once it is removed from this side, it means this side now it has been shortened. So we lock it. This can be locked. There is a hole and there is a pin with the interplacer. When that pin will go through this the sprocket, and then that pin end will be on the interplacer, so it will prevent the turning of the camshaft. And that time, after removing the link, we join together. After that, we have removed 2 link. With the chain block, we push it up, and then we put it 1 link on this side. 1 link will be this side, another link will be this side. After that, we check the timing. If the timing is okay, okay. Otherwise, we need to adjust the timing if the timing is not okay. So this procedure, now let us see how we remove the link and put back the link. So one way we can do, we can put this tool so that we push this pin towards inward direction so that it become, the clearance will exist. There will not be, it will be, load will not be there in the pin. After that, we can break we have the link chain breaker. We can break the chain at this. It means if we remove the pin, your link will be free. We can remove the link. For an example, suppose now we have put this tool, tighten it, what had happened? There will be clearance here. All the pin, bush, there will be clearances. And once there is a clearance, the pin, the riveted end, we can chisel it out or grind it out. Once we grind it out, then we can push from this side, the pin will come out, then the outer link will be free. What we do, these two pin we break. This one and this one. Once we break this pin, how many link we have removed? 1, 2, 3. Whereas we need to change 2 link. It means we have removed 3 link. But once we have removed 3 link, what had happened? This is the position. So this is inner link, this is inner link. Now, what we can do, we are adding one outer link. So ultimately, after opening, what will happen? We'll be tightening this further. Once we tightening this, because this end has to bring closer. Once it brings closer, then we put this outer link connected onto this. So ultimately, how many link we have removed? 2 link we have removed. Here we have removed the 3 link, 2 adjacent outer link. After that, we can put this one new outer link onto this inner link. What will happen? It will then, this link is a new link we have fit here. Or we can remove this and then you bring this and fit it here. So this link is removed, this link is removed. So the 2 link we can remove. Because 2 link is the maximum allowable link we can remove. So this outer link will connect, this point will connect to this. But make sure you are using the pin is a new pin. Usually that's why 2 adjacent outer link is removed, new link is put. Because once it is used, we don't reuse unless it is an emergency. In that case, we reduce the engine load. Is it clear, understood how we remove, but exactly what we do for removal, that we'll see. But how many link we remove and then how we connect it. Because we bring the slack to this side, then we tighten this. And once we have tightened this, after that we break it. We remove 2 outer link, 1 inner link. After that we push close to, we put a new outer link here, and after that we push it. This distance we reduce, we can reduce the distance by tightening this nut. After that, this will be aligned, this hole and this hole will be aligned, and then you put the pin and we rivet it. So that is the way we can shorten the chain length. Once we shorten the chain length, this will be on this one side. So after that, we lock the sprocket of the camshaft, and then we, with the chain block, we lift it up, and one chain link we shift on the sprocket. It means we have the sprocket, there one link is there, this will lift, and we put this link on this sprocket. So this side we have adjusted, 2 we have removed. Now what will happen? It means it will be, we have removed this side, this one will put it here. So now it will be, both side will be 1, 1. We have reduced. So that is the way it is done. Is it clear to you all or not? Can you hear me now or still having the problem? Can you hear me? Have you understood what I said?
Yes, sir. Now is okay.
Okay. So this is the way we remove chain and adjust the length. Now after that, we need to, as I told you, that we shift one link to other side, means the side where we have reduced, so that it become equal both side. And after that, we need to check the time, and this is done by locking your camshaft. Camshaft can be locked with that pin what I told you. And then you turn the engine 1 revolution, so that after that you check bring the TDC number 1 unit, and then you check the timing. It means first you check the retentioning of the chain. Again, it is a long procedure. First you have checked the tensioning, and you have checked the length, You have found out that the length is more. You need to remove that link, two link you have removed, assembled. After that, you need to check again tensioning, because tensioning has to be adjusted now again. So if change tensioning, you adjust, and then you need to check the timing of that pin gauge you will be using to check the timing. So after that, if the let us see before we go into this how we break the chain. So this is the way we can break. One of the way, there are different ways. This is one of the way we can break the chain. So this is the tool. This we grind it. This is the riveted pin, and we grind it. After that, there is a thread. With this ratchet, we turn it, angular displacement we give so that it moves downward, and it is hold from the bottom. Bottom means it is the link plate is hold here. It is not, this plate is hold here so that the force is applied in this direction so that it is interference phase, and it will push down, and then it will come out from the link. The pin is removed like this. So if you see this tool, the bottom, this plate, it's in two half. It is not continuous. Top side is continuous, so that you can put this tool and put this inside, and then it will hold. It will not allow this plate to move down, so that the pin can be pushed downward and the pin will come out from this, and then you can remove the link. After that, you can assemble it. How do you assemble it? Let us see. This is the way we assembled, one of the way. In this case, we put the plate. This is the plate which we are connecting. So this is the one heavy piece. We keep it at the bottom on the other side, and then this is the punch. With the punch, we can do it means we put the plate, these two plate. From the one plate will be having the pin which is attached to, and after that this pin will come out from this. You put the plate, and then this is the plate outer link. This is another outer link, and the pin is attached to this outer link. And we have put it like this. After that, you put this plate. If you punch it, what will happen? This plate will move down, whereas it will not damage your pin soft side, where you will be doing the riveting. So there is a gap here. That is the reason, which will be higher height than this, as well as the diameter will be higher. So after that, once you put this plate, after that you will do the riveting on top. So this soft surface, it means your link plate will come here, and this will be projected out, and then you hammer it, you make it. So is it clear how you assemble it? How you remove and how we assemble it. This is one way, but there are other way also it can be done. So this is another way. You have the straw, you have the ratchet, so that you can tighten it. Once you tighten it, what will happen? There will be clearance exist between the pin and the bush, and then you can break it. And in that case, the breaking tool also can be, there are different types. This is one of the type of breaking. Yeah, tell me, is it clear to you all? So this is another type of breaking. Let us see this diagram, you'll come to know. This is the way it can be break, and again it can be put back. In this case, if you see how it breaks, you remove the rivet by grinding. After that, you put this tool, this tool is holding this plate because this has to come out from here. Once it comes out, other side, the plate, outer plate is having that together with the pin, it will come out. Only it has to come out from this distance. So we have this tool. Once you have clamping onto this, then you have the bolt. If you are tighten,
Good morning.
good morning, sir. Yes, sir.
Chief Das.
Yes, sir.
Good morning.
Good morning, sir.
Hello.
Yes, sir. Tell me, sir.
Can you hear me?
Yes, sir. I can hear you now.
Connectivity is not good.
Yes,
Is
sir.
it?
Today.
Is it? How is it the connection?
Today,
Can you hear me
I don't
properly?
know. It is happening today. It's coming and going, the internet.
So, of course, I was out for some time because I had some paperwork.
Yes, sir.
What time you had is coffee break?
This is, we
Did you have
complete
coffee break?
till 12 o'clock. 9.
There should be some enough coffee breaks
Yes,
for
sir.
the next.
There was an internet connection again problem. So can you tell me, sir, actually till now we
Yeah.
are not giving coffee break because we are shortened the time. Morning we have the 2.5 hours, 9:30 to 12 o'clock. But in between there is no coffee break till now we had given. And
Yeah. You see, otherwise, if you don't give them this coffee break, at least 20 minutes like that, it will be boring. Huh? Just the capacity of absorbing the lecture will be, it's not, it will not be to the mark. So you have to consider this one
yes,
during the lectures. You have to tell your colleague, electrical lecture also. Huh?
yes,
It is a proper, you have to have. Otherwise, it will be boring for them. Huh?
we'll give the break, sir. In between 10 minutes around, 10, 15 minutes, we'll give the break.
I think 20 minutes is good, huh?
Yes, sir. Then we'll
20
give
minutes.
20 minutes break, we'll give.
20 minutes is good.
Yes, sir.
Yeah,
And
yeah.
this
For every
connectivity, sir,
lecture.
today we are having problem. Usually we don't have this kind of problem. But one of the student was telling maybe because of the holiday, everybody is using the internet, maybe because one of the reason.
Okay, now okay, just I'm out. Okay, just this is only to convey my message regarding this. Okay, you continue. Have a nice time.
Thank you, sir. And we'll give the 20 minutes break in between. We'll plan for that. And we'll give from next class onward, lecture onward.
Okay.
Yes,
Okay.
thank
Okay,
you,
that's
sir. Have a nice day.
okay.
Sir.
See you.
Yes, sir.
Yeah. Okay, I'm out.
Uh, so, yeah, there was a lot of disturbance today for the connectivity. Previously, it did not happen like this. So this, tell me, this tool, have you understood? Because this tool is it is holding the outer plate, and then against outer plate, you are pushing this pin in this direction by tightening this bolt. Once we are tightening, it's like a jack bolt. It pushes, and then pin is moving out because it is interference fit, and pin together with this plate. It means if you see this, when it is coming out, it will be like this. So there will be a pin, with the pin it will come out. So this pin, this end only interference fit here. So once we have this tool which is holding this plate, and then from top exactly it is made such a way, this, when you tighten this, it is moving this direction, and that will push this pin. It means this pin is pushed out. Once this pin is pushed out, pin together with the opposite side outer link will come out. Once this has come out, it means it has come out, this one link come out, here another link come out, and then we have two link, outer link, and the inner link, one inner link will be removed. After that, you pull this direction, and then one new outer link you fit with this place. It means this has come out, means there, here there is one inner link, and this there another inner link. These two inner link will be connected by the one outer link. Is it clear how you break the link? All of you, is it clear? Can you hear me or no?
We can hear you, Chief. But
Yes,
can we go through it one more time, please, Chief?
Yeah. So this one, if you see this tool, it means we have the outer plate one, another outer plate here. And this is the inner plate. And this is the pin. And another pin is here. And we have the pin, another pin is here. And another pin link is here. So in this case, if we put the tool, this tool will hold here and here. And this plate is, this is the plate. Now we have the threaded hole in the plate. This is another pin which we want to push it, and other side there is a link, outer link, together with these two pin will come out. So there is a bolt, threaded bolt with the head. And we can turn it. Once we turn it, what will happen? Before putting this tool, what we have done, we have removed this rivet with the grinding. Now this pin is interference fit here. We have already removed the rivet. So now we have put this tool which is holding these two plates together. It means when you are pushing this bolt is pushing the pin, there will be a relative motion between the pin. Pin will push down, but not the plate. Plate is holding at this point. Can you see the arrangement here? It is holding the plate. So plate will not move down. By turning this will move downward, and it will be exactly aligned with your pin, and the pin will be pushed downward both together. So the pin together with our outer link on the other side will come out. So will be remaining after coming out from this, and top also this plate can be removed. After that, this will be a inner link, this will be another inner link, and this two hole will be there. And we remove this one set, another set here. So here one outer link, inner link, outer link. 3 link we remove. Once we remove the 3 link, now the removal, okay, have you understood or not? Now, this tool. About this tool, have you understood? Tell me.
No, Chief, I don't understand. No,
Okay.
Chief.
So, let us see this diagram. So, this is the link arrangement. Now, suppose you put a tool which can hold here these 2 plates together. Here also same leg is there. There will be 4 legs. 2 here, other side. So once you put, there is a plate here. And there is a threaded hole here. And we have the threaded hole in line with your...
So, sorry, I can't understand me also. I can't hear properly due to the connection.
This arrangement, have you understood or not? This arrangement, this is the pin
Yes, I understand.
link. Now this is the tool. Tool is like this. Okay, it has got leg. One, two, similar leg, and other side also we have. We have 2 other side also. And here we have hole, 2 hole. And these 2 hole exactly the pitch. Now this one we can put from the side. Once we put from the side, what will happen? This will come, this portion will come here. And this hole is the threaded hole, through which we have the bolt, jack bolt. This jack bolt, if you tighten it, what will happen? And it will be exactly in line with this. This rivet we have removed. Now what we need to do? We need to have a force which will move this pin downward, but this plate will move, should not move downward. Now if you have a bolt which is pushing at this point, it is holding here. So what will happen? There will be a relative force. This will be the force downward, which will push the pin downward, but not the plate. Is it clear now?
Yes, it's clear.
Yes, sir.
For me.
Yeah, it's clear. Now it's clear.
So both we remove, now this we remove, so that once we remove this together, both together, we can. Actually, this will be extended up to this. And what I had shown for your explanation, this one will be here. And there will be 2 jack bolts. So the 2 pin together with this outer link will move